In this video, I want to take a look at the sum of a couple of cosines, because that's what we're getting for solutions to the undamped forced vibration problems. So what I'm doing here, I'm using Mathematica, and I'm plotting R1 times the cosine of bx minus d1 at plus R2 times the cosine of wx minus d2. So R1 and R2 are the amplitudes of these two cosines. B and W are determining the periods of the two cosines, and D1 and D2 are determining the horizontal shifts. Okay. Now, I have, I think I have 3 and 5 as my amplitudes right now. I don't know, but I have two different amplitudes. I have two different periods. I believe both shifts are at 0. Okay. Now I can grab these sliders and change them to change amplitudes of things, or I can change the periods, or I can change the shifts. And it's kind of fun to play with these sliders and see what all happens. The thing that I really wanted to see when I was investigating this was what's happening when the two periods are getting very close together. And what happens is beats. These we heard on the tuning the guitar. These you saw in the vibrating spring that got really big and then back to small again, and then big and back to small again. We can see that as the two get closer and closer together, here we go, closer together, that those beats stretch out really long. As I pull them apart, the beats get short. So we get longer and longer beats, and there the two strings are in tune, right? And then of course on the other side it goes the other way. So the mathematics that I can do reasonably easily is to show that if I have unshifted cosine curves with the same amplitude, that they definitely have these beats, and these beats go between an amplitude of 0 up to an amplitude of twice whatever the individual amplitudes were, and then back to 0 again. But if they have different amplitudes and have different shifts, how does that work? So I just wanted to play around, and I can see, I can get to a point where I've got beats, and the shifting doesn't really change the shape of the beat. It shifts. I'm only shifting one of the cosine curves, and it shifts the beat around, but it's still a beat. What is happening here is because the two amplitudes are different, the smallest point here, the smallest amplitude doesn't go down to 0. When I get these two to have the same amplitude, the beat will actually have a 0 in there. When I get these farther apart, you see that it gets bigger and smaller, but the amplitude never goes down to 0. Okay. So that was one thing I wasn't completely sure of before I started this, as to what was the effect of these things, these different parts, the shifting versus the amplitudes. And it's the amplitude really that is making it so that the beat does shrink down to an amplitude of 0, or if they're different, then it does not. Okay. But the shifting of the individual cosine curves doesn't change the shape of the beat. The amplitudes do. So that's an interesting observation. However, whether the beat gets all the way down to amplitude of 0 or not, we can still see that the effect, whether one amplitude is bigger than the other, the effect of getting the two periods close to the same causes these beats